Okay folks, welcome back. We're in 8.1.1. We're looking at graphs with asymptotes. Always a fun word and fun section here. So, a mathematically clear and complete definition of an asymptote requires some ideas from calculus, but examples of graphs with asymptote might help you recognize them when they occur. In the following examples, the dotted lines are asymptotes and their equations are given. In the two lower graphs, the y-axis, or x equals 0, is also an asymptote. So let's take a look at these graphs here and talk about asymptotes. So the dotted lines, these are asymptotes, guys, right here. The asymptotes are not actually part of the function. They're invisible lines that the functions approach, but they are not actually the function. So these dotted lines, these are the asymptotes. And the functions themselves, we have a fun word for those as well. When a function has an asymptote, it's asymptotic. So we have asymptotic functions that approach asymptotes. And I have the asymptotes here in blue. So these are lines that the function approaches but never quite gets to. So we get closer and closer to this y equals 3 line, which is this one right here. As the function goes to infinity and negative infinity, so here it's going negative infinity, it's getting closer and closer to that blue line, but it never quite gets there. Same thing here for this one, closer and closer, never quite gets there. Also, our x equals 2 is a vertical asymptote on this function, and we see that the same thing is occurring. The asymptotic function is getting close to the asymptote but never quite getting there, and in the negative infinity direction of the y, the same thing is occurring. You can get functions like this that have this wavy pattern, called dampening functions. They occur a lot in probability, actually. And so you can cross that asymptote. In this case, the asymptote is y equals 5, the horizontal line y equals 5. But the function itself is just continuing to approach that value of 5. And it's hopping back and forth on either side of the 5. And as you go closer and closer to infinity, it is going to get closer and closer to that 5 value. You can have a crazy curved asymptote like you have here. I'm guessing this follows some sort of parabolic function. Our asymptote there is the blue line, and the functions are the asymptotic functions that are approaching that blue line in a couple different directions. Oh, and it looks like we might have an asymptote in the vertical direction as well. We might need to see a little bit more of that to be sure of it. Here we have a diagonal asymptote. And another vertical asymptote as well. So it does tell us up here in the lower two graphs, the y-axis, or x equals 0, is an asymptote. So those were both, there's a vertical asymptote here and a vertical asymptote here. So as you can see in the examples above, the asymptotes can be diagonal lines or even curves. However, in this course, asymptotes will almost always be horizontal and vertical lines. The graph of a function has a horizontal asymptote as you trace along the graph out to the left or right. That is, as you choose an x or y coordinates further and further away from the 0, either towards infinity or negative infinity. The distance between the graph of the function and the asymptote gets closer to 0, so they get closer to that asymptote. A graph has a vertical asymptote if, as you choose the x-coordinate closer and closer to a certain value from either the left or right, or both, the y-coordinate gets further away from 0, either towards infinity or negative infinity. So there you go, guys. That's asymptotes. Let's look at a couple examples on the next slide. I have 3 functions here, and I would like you to take a look at those functions and sketch them in your notebook and then tell me what the asymptotes are. I'm going to zoom in on each of them for a couple seconds. You can pause the video if you need to so that you can see those more clearly.